afternoon, in this last session, we've got Juan Berner from Argentina, who's currently living in the Netherlands, talking about how to build your own WAF. So please welcome Juan.
Hi, thank you. So, yes, my name is Juan Berner. This talk is building your own WAF as a service and forgetting all false positives. This is a bit about me. So I am lead security developer at Booking.com. I work mostly in this kind of solutions architect role for both application security and infrastructure, so security data pipelines, and in this case, solving application security problems like web application firewall. So to have a quick overview, we'll look into what a WAF is and the deployment modes, then the concept of a WAF as a service and what changes from your usual WAF setup, then about how can we block attacks without false positives or adding latency to customers, and finally, if we have some time, a demo. So just to have a small summary of what a WAF is, it's a web application firewall, so focused on layer 7, so the application itself, and it looks into application attacks like SQL injection, remote code execution, and basically that's it. So to go a bit into the different deployment modes that a WAF can have, one of them is inline mode. So the benefit is that you can actually block attacks when you have this deployment mode. As you can see, the WAF is in the middle of the customer and the web server, and it's transparent for web servers, but the downside is that now you have an extra point of failure, you have added latency, and of course the network placement can be very tricky, especially on large organizations which might be across the globe. Then you have out of band. Out of band means that the WAF is inspecting the traffic, maybe for example with a tap, a network tap, but it's not able to block because it's no longer in the middle of the traffic. You don't have latency, but of course you can only know that attacks are happening. You cannot do much about it. And of course when you have things like perfect for secrecy, it can become very tricky to this kind of inspection. Then a newer deployment mode has been the agent mode, which means that, for example, a web server might have an agent in the same host, and it's very easy to place and simple to scale. You just scale it with your web servers, for example. But the downside is that now it can be a lot more invasive and it can make the resource allocation trickier or less efficient. Just imagine that if your web server is using 1 GB of RAM and you're using containers, suddenly every single container has to have its own WAF container in its pod, which might be using 3 GB of RAM. And finally, cloud. So you might know a lot of cloud providers, and it can be quite convenient if you are using a cloud provider and you just use their WAF services. But of course, if you are not in the cloud, it's out of your control, it's added risk, and the latency can be pretty substantial to the point that you might not be able to use it. So what are the usual problems with this kind of WAF solutions? So the network placement, I mentioned it, the availability and performance concerns, especially from the developers who might see the WAF as an obstacle to their reliability, or at least a black box they might be afraid of, and the false positive rate. So how many of your actual customers is the WAF blocking, which unless you're tuning constantly, especially on very dynamic environments, can become a reason not to be able to use a WAF at all. So how did I end up with this kind of problem? So at Booking, we worked in a very challenging environment, so it's a very dynamic environment. There was no acceptance for false positives, a reluctance towards black boxes, and we wanted the blocking to happen through the application, which okay, a lot of WAFs allow you to add the data on the headers, and then the application can block it. But the added latency that all these inline WAFs have would not be acceptable. So basically, we need to be able to block attacks without any latency added to users and no false positives. So simple problem. So here's how I ended up with this architecture. So having a WAF as a service. So it's going to remove false positives by understanding the context of the request, not just the request itself. There's no need for an appliance, so any application can just add an API call if they need to quickly bootstrap, something which developers are very used to and very comfortable with. And of course, the application has a lot of power to decide how the WAF is going to react, and it also allows to avoid the latency of the users, something that I will explain later how. So just some stats on this architecture. We block about 11 million requests per month. 7,000 distinct fingerprints. I will explain a bit more what a fingerprint means afterwards. And no added latency for regular users, and no known impact of false positives. So this talk is about how could you build one. So this is all based on open source components, so nothing proprietary. You will need to have a log processing pipeline if you don't have one. By log processing, I mean that you are consuming events or logs from your web servers and then doing something with them. For example, a very simple approach would be if you were visualizing some stats on the logs of your web servers. Having a WAF as an API, so no longer just a box that you place in the middle of the traffic, but an API that can be called and can answer information, and might use something like a library to having these logs sent by the web application or calling the API itself. So for this talk, to explain this, I created a case study of a web application. So in this case, we will have a simple web application, which I'm using Flask. All this code of all the things I'm talking about is in GitHub, and also the demo. So when I'm doing the demo, I'm just running a Terraform script to build an infrastructure in Google Cloud based on the code in GitHub and show it. So you can do it yourself afterwards if you want. So how do we get this middle ground of having out-of-band capabilities of not affecting latency, having inline capabilities of being able to block, and of course getting the best of both worlds without false positives? That's what this talk is about. So I'm going to go first all over the whole architecture of this. So you have there the web application. I will go into each component, but just to give you an idea, at the bottom you have the out-of-band capabilities or components. So basically something that's reading the logs and doing something with the logs while not adding time to the web application itself. And at the top you have the, let's say, inline world. So the web application talking with the WAF, which is now an API, and deciding if they want to block or not based on the response. So I mentioned the web application component. You can think it as any web application that you might have, so Python or Java. Then the agent. The agent is going to be the one that's actually talking with the web application. So there, for example, it's a very slim agent, so it doesn't have WAF capabilities. It doesn't understand if something is an attack or not, but it's the one to decide if it should call the WAF and get information as an API. It's very simple to set up, but of course you have the issues I mentioned about agent implementations. Although if it's a minimal agent, you're not going to have the efficiency problems. A simple approach might be a library. So just imagine that you have any library which does API calls to a service. This would be a simple library on the application that can do an API call to the WAF service at the beginning of the request, for example, or after looking at the content. There are inherent risks with this approach. While it's very simple for any developer to just bootstrap their application, what can happen with this is that you are no longer, the WAF is no longer protecting the application framework itself. So if you have a vulnerability on the web application framework, let's say on Flask, how it processes a request, it's going to be too late already. But depending on your risk acceptance, this might be a very simple way for you to start getting this 99% of coverage on these attacks. Now the WAF service. This will be the service or the API that's going to receive a request with information of what happened or what the web application is getting. So it's going to have a pluggable architecture, and which means that you can have multiple components which can work in parallel, and it will return to the application. It's not going to block, it's just going to return a recommendation. For example, you should block an attack. So these components can be of three types. One is open source components, so mod security or NATC. I'm using mod security for this talk and for the code. And other components might be proprietary. So let's say that you are using mod security, but you want to test a commercial appliance. And it's a simple way of evaluation, because you could now have the WAF service return the recommendation of mod security of the appliance, and afterwards you can just compare in what cases is mod security better than appliance, or what cases the appliance is better than mod security. If anybody has done a WAF comparison, it can be very tricky to do this kind of implementations. Most of the time you do it out of band, but getting the coverage just for a POC can be a daunting task. And the other option is custom modules. So for example, for this talk, I built two modules, one which would be rate limiting, and the other one which is a very simple rule engine. but you can imagine that there are, from the application side, modules you might want to create custom for your environment, or for example, if you want to use machine learning models because you have some fraud situations and you want to learn a bit of your customers, or custom business logic. So now this is how the WAF service would look like. It's basically this API which would have its parallel components called and give back a recommendation. Now, the log processing component will be the one that's getting the logs from the web application, which would have encrypted data of the request, and will be able to replay the request to the WAF service. So out of band, if the WAF service is taking 100 milliseconds, doing this calls, which will take 100 milliseconds, and then enrich the logs with this information. So now, if the application has not gone through a WAF service as an API and not added that latency, it's going to find out about it afterwards. So in this out-of-band mode. And in this case, I'm using Dataflow, which is a parallel processing framework with Apache Beam, just so I can use the capability of working with windows of times and doing very naive score calculations based on it. And finally, detection. So if the out-of-band process detects that sees in a window of time something that considers the score is high enough, it will send it, in this case through a queue, to a detection service, which is going to use the information received and other information to make a decision based on it, to decide if something is wrong or not. And this information it will use will be about a business value, patterns of behavior in history. That's why I use Google BigQuery. You can have petabytes of information and in seconds get a response about a particular, let's say, endpoint and how common are their false positives for some messages, which might be more common on an application which is getting chat messages than on an endpoint that is just getting the same values all the time. And finally, the state store. So a place where we're going to store some data, which should be quite fast to retrieve, and ideally you should be able to cache. And one more component will be, of course, visualization. So you want to be able to visualize the information. I'm using ELK, so Elasticsearch Logstash and Kibana, and it will allow you to understand the activity of what's going on, both inline and out of band, have some metrics on the time that it's taking, especially for the inline, so how much time is it adding or latency, and the visibility on the attacks, who is attacking, for example. So these are just sample dashboards that you might create. In this case, for example, there are 3 different components and only mod security thinks it's an attack. There are 2 components say this is not an attack. So the recommendation is we should block it. And one more component I built just for this talk, which is a management command line tool, so that you can configure this. I'm going to use it on the demo. So now that we have covered how this architecture looks like, then the question is, how do we block? Because I mentioned we don't want to have false positives, so we don't want to block. But at the same time, I did mention, I talked about false positives. So that's why it can be a bit tricky to understand, in particular, that there are 2 types of false positives. So detection of false positives and blocking false positives. But first, on how do we decide something to be blocked? There are 3 ways I mentioned. So one is fingerprint-based routing. So at one point I mentioned 7,000 fingerprints. By fingerprints, I mean ways to segment the traffic. So you can imagine the normal thing of an IP address, a user agent. You would want to be more advanced than that. So ideally, you will go to a step where you are basically looking at what looks like suspicious traffic and finding the way to cluster the traffic in the manner that affects only the suspicious traffic. And then you will be able to say, okay, this suspicious traffic, I want to actually place it inline. So in this way, you don't have either out-of-band or inline mode. You actually have both depending on the suspiciousness of different fingerprints. Another option is by their net blocks. So you could say, for example, hosting providers, particular ISPs, proxies, or Tor exit nodes. You don't want to block all the traffic, but you might be able to say, okay, based on my history and how many people actually use my service from these endpoints, or I mean from these IP addresses, I want to add their latency, so have extra latency and have them always in an inline mode. Or virtual patching. So there might be, you get a call at 3 a.m. and there's an endpoint that you know that a particular parameter we have discovered it's vulnerable. So you might say, okay, for this particular endpoint, any request that's going there with this parameter, I want it always in an inline mode. So always adding latency for this. Now back into, that's how we actually segment the traffic to decide what goes inline and we can block. But how do we manage the false positives? Because that's the problem. Like mod security, if you aren't tuning it constantly, especially in an environment where people are spawning different applications all the time, can have a lot of different false positives. So here's where I differentiate between detection false positives and blocking false positives. So detection false positive, I mean something like mod security sees a request and says, okay, this might look like an SQL injection. Blocking false positives, I mean we have actually blocked a request from a customer which we thought was dangerous, but it wasn't. So this manages to remove the blocking false positives. And how does it do it? By looking at the context. So what do we check? We check business logic. So how trustworthy is a user and IP that goes back into the storage like BigQuery, where you would have this information. Business activity from the endpoint, and what would be the impact to block it. Historical analysis, based on this, like for example, if we're in an endpoint that has a lot of detection false positives from mod security, you might not want to say that something is suspicious if you see a single SQL injection. That might actually affect the score for you to decide that a particular segment of the traffic is suspicious or not. And of course the context. So in this case, if somebody has 3 or 5 detection false positives in the same 30 seconds or in the same minute, then that context changes a lot. And it means that this is probably an attack. So to give an example of what I mean by this change of the context, let's do an example with the sleep. If you have this kind of message, I will sleep for 1 or 2 days. Mod security is going to think this is an attack, right? You might want to tune it and say this particular endpoint, when you see this, you want to increase the score or decrease the anomaly score for mod security. But in the end, this might change too fast for you to do it, and you will find out because people are complaining that you're actually blocking real customers. Now, if you say that, for example, SQL injections with mod security have a 0.1% of false positive rate, that's pretty high. But if we go with a very naive approach and we say, we actually want to get to 0.0001%, which is going to be close to nothing from your perspective, then you will say, okay, I just need a score of 5. Since these are independent probabilities, that means that that becomes that this is the probability of a user actually creating these 5 possible SQL injections, which are not SQL injections, they're actually the current customer. And when you add this to all the information you have from the context and history of the endpoint, it basically becomes practical 0, the probability of getting any blocking false positive, or a customer actually getting blocked. Of course, this aims at attacks that need volume, like, for example, SQL injections. If you're worried about things like a 0 day, that you know, okay, this particular request is going to immediately create a remote code execution, at that point, you would want to have this kind of fingerprints in the cache. Or if it's an endpoint, like you're working with a very sensitive endpoint on a bank, you might be able to say, okay, I cannot accept any risk. But this is geared towards the places where you might want to accept some risk, like 1 request or 2, and you're finding out afterwards, and removing all the false positive impact and all the latency concerns. So this is basically how the hybrid mode would work. So the benefits I mentioned are that the WAF does not add latency for good users, because once you turn this in practice, the traffic that you're routing through the WAF is just the traffic that you have detected suspicious. And this can be in a couple of seconds, depending on how you are creating your out-of-band components, depending on what you use, right? And of course, what you want. And that has a lot of flexibility, because now you can add as many components as you want. So it's no longer the WAF mod security, it's the WAF any component that you want to have, all in parallel, making the slowest of your components the slowest response you're going to get from the WAF. So you might want to have your own bot detection solution, or something that analyzes Google reCAPTCHA, and all of this information will be able to allow you to decide if you want to route traffic and block or not. And of course, this removes the false positives, because you are now looking at a context. You're no longer looking at single request, which might have a false positive. You're looking at a context with some historical information which will allow you to decide if something should be blocked or not. And the caveats. the delayed response time might be prohibitive for some endpoints depending on your risk. So if you cannot have like 1 second or 2 seconds of requests which are not going in inline mode, and the increased complexity, which if you already have your log processing pipeline because you are getting access logs from Nginx and then doing something with that, it might not be a lot more, but if you don't have anything of that, it might mean having more components. So yeah, so this is it. I will try now to do a demo, if everything works.
Break the gods.
Yes.
Sacrifice.
So first, let me show you, for this demo, I have everything on Google Cloud using the Kubernetes engine. So it's taking a bit, the command. So here we have the demo web, which is a Flask website, Elasticsearch Q1 and Logstash, which will give the visualization.
Can everybody read that at the back?
Oh.
Just think you might want to, yeah, slightly bigger.
So yeah. Then you have Redis, which is the storage. I just created this container, which is scanner, which is doing every 1 hour or 30 minutes SQL map and some other scans, and the WAF service, which is the important one. And then, of course, the alerter, which is the one that's detecting and deciding, okay, this traffic should be routed through the WAF. So let me see if the proxy is there. Now let's do a test. So first, I'm now in the WAF service where I have a command line tool. So here I have the configuration. So I have the request stage, which means when the website gets a request, disabled, so nothing going on, no traffic will go inline. This is probably the IP of the alerter of the scanner, so this was detected automatically. And what I'm going to do now is just go to the website I have here. So this should load, works fine. Now I will try, for example, to do an SQL injection, which should be picked up by mod security. So this is working because there's no mode enabled, so the WAF is basically disabled. So the first thing I will do is I will configure this to block so everything goes inline. So we want all the traffic to go inline, which is what usually happens with a WAF. But of course, every request is adding latency. So you can see it took a lot longer. And now, okay, it's blocked. This is great, but we actually care about latency in this case. So what I will do is I will change the mode so that now we see that it's configured as identifier mode. This means that when I do this request, it knows that it should not go through the WAF because it has seen that only a single request happens. There's no information on the state saying that this is bad. So what should happen now is that behind the scenes, the out-of-band architecture or data flow is looking at all these requests I just made, sees that there's an attack going on, and decides to take a fingerprint, so the IP address, as something that should route the traffic. So if I check now the config, you can see that now this IP address has appeared, which should be my IP address. So if I refresh now, this is now inline mode. So what happens basically, a couple of requests happened. The out-of-band process looked at this request. Actually, we can see this in Elasticsearch. They saw that traffic, and so this is the traffic that was generated. Let me see if I see more IP addresses besides mine. So it's just my IP address. Now, what happened here is that most of the traffic happened on replay, which means that it happened in the out-of-band mode. At some point, the out-of-band mode sent to the alerters component or detection component, hey, I see this weird traffic. The detection component did a query to BigQuery and checked, okay, is the context of this something that I should use for my scoring? And decided this is traffic I should route because it looks suspicious. And afterwards, the WAF the requests were inline mode and in the request stage. So if we just look at the time of the request, we can see that this request, for example, let's just look at was on the replay stage, the WAF review, but afterwards it went on the request stage, because at that point the cache was updated. So now let's do another example. I will just delete these identifiers. And let's say that we have, for example, an endpoint. So we have a ping endpoint. And in this case, again, it's not going inline because I just deleted from the cache. So if I do a couple of more requests, it will go back inline. Of course, in this case, you wouldn't delete the cache would stay, depending on what you want. But what we can do in these cases is have the flexibility to say, okay, we actually want to virtually patch this endpoint, because we know there's a vulnerability on the ping endpoint. So now, this should be blocked. Because now this particular endpoint, or particular endpoint and parameters, we are saying that we want it inline. So in a way, we are basically deciding, depending on automatic detection or manual interaction, how we will route our traffic, if we want it to go inline or out of band. So not based on a particular web application, but particular traffic itself, based on how you detect it.
So if I was to ask a question there, you basically just patched your mod security rules to actually do it inline at the front, or something like that?
No, so maybe I can explain now. So let's go to the next slide. So let's go through what happened, right? Because it can look a bit, it can be hard to explain. So first, we have the first request. It went to web server, right? So web application and returned the AusCERT logo. Now, what happened behind the scenes is that the web application has a cache of the storage, which checked, is there anything from this request, like the IP address, the user agent, or whatever combination you have, which I think it should go in an inline mode. There was nothing because we just started it, and that means that after it responded to us, it created a log. So that log had information of the request, which didn't go in inline mode, got into the out-of-band processing component, which is data flow, and data flow said, okay, this request, I will do a request to a WAF API, and actually, let's leave it there, a request to a WAF API, and got as a response, not if mod security should block it, or, well, not just mod security, but the rate limiter, mod security, and the other components, what they thought about it. So do they think it's correct, or it's an attack or not? Then, after a period of time, because I did like a couple of requests, Dataflow said, okay, in a window of 30 seconds, I saw 5 requests which look suspicious. Let's send update to the detection module saying, okay, this particular fingerprint I just detected looks suspicious. Where you still should not say, okay, I should block it. This is your opportunity, because you now have like 1 second or 2 seconds to say, okay, actually, let's query information I might have in databases, I might have on my history, to get more context on this. Because maybe this is an endpoint where I want to not just say 5 SQL injections are bad. Maybe in this endpoint, based on the historical score, I want to think that 10, because everything is considered, because mod security is not tuned, for example. At that point, the storage was updated with this fingerprint, in this case, this IP address. So the next request that I did and went to our application, checked the storage, and since the cache had been updated, and now it has an IP address, and since this is an update on a cache, that means that it's not like every single request adding like 5 milliseconds to Redis. This happened once, or a different thread depending on your language. And then, since we had that fingerprint, this traffic was now routed. So only that request, when it could see the fingerprint on the cache, became an inline request, adding the latency. And since we have some context to decide that we should route the traffic, we are pretty confident this is malicious, then it's no longer affecting with false positives. Because at this point, the probability of we thinking a fingerprint is malicious is very small. Of course, one thing that could happen here is if you have a very naive way of fingerprinting, like just the IP address, or worse, an ISP, that would be terrible. So you never want to go with something like that.
So
yes.
If I was to go back to that previous slide, if you don't mind, if I was to ask a question, so basically, initially, everything does it in parallel processing. Then you get the flag set in your storage database that says, we now do it inline. At some point, does that get updated and say, we now set that to blocking mode and it doesn't even do it inline, it just drops it straight away?
So your question is that instead of going to a WAF, the web application itself, before asking a WAF, just blocks it?
Yes.
So the idea would be no, because you don't want to add this logic to the, so there's two things. One is you don't want to add the logic to the application, so you want to, or the agent or the library, you want to keep it as thin as possible. The second one is, as I mentioned before, if you have a fingerprint which is not completely unique for the malicious actor, in this case, the normal users in the same ISP would still be working, just that they would have extra latency and affected by the false positive rate of detection. So that means that if you have a very naive approach, you put a whole ISP, and some people are using a proxy in Google Cloud, then you're adding them a bit more latency, but you're not just blocking all the traffic. You're just blocking whatever it looks like an attack for mod security or for any of your components. Yes?
What happens if your first request is malicious?
Just repeat the question.
Yes, so
the first request is malicious, does it just serve whatever? Or?
That's the part of, okay, so the question is, what happens if the first request is malicious? Here's the tricky part, which I mentioned in the caveats. If you know that, for example, some particular fingerprints allow you to understand that this is a 0-day, you would want to have them on the cache. But let's say that you don't know about this and somebody just got the perfect SQL injection, which is not blind, so it actually just dumps all the database with a single request or a single remote code execution. That means that the first request would pass by, but then it would still detect it afterwards, so your analyst would know about it. But then, of course, if it continued with more requests, it would again start going inline. But that's basically the risk. If you think that a single request is going to basically drop your entire website, then that's a risk where you might want to have everything inline, or even yet, depending on some endpoints and their criticality, you might want the whole some endpoints to be inline. So some particular URL paths, for example.
And that's one of my follow-up questions I want to ask is, have you done any profiling to see how many requests somebody might actually do as a targeted, pre-profiled attacker, potentially being able to compromise your database once they've realized you've got this structure in place before your parallel processing actually can drop that indicator, that endpoint?
So I don't have data to support this. My only analysis is that for sure this can happen in two cases. One where it's something like a 0-day or some kind of vulnerability which is well known and unpatched. So there are a couple of ones with a single request, at which point you would update the state storage. Or if, for example, either an internal insider threat or somebody who has access to your code is able to, for example, do the thousands of requests you need to find an SQL injection or remote code execution, finds that one in, let's say, a parallel environment, and then uses that request. So those are the risks to take into account. And depending on your application, it might be a risk that you can accept or you cannot accept. Because you're still finding out about it afterwards, but that means that you haven't blocked this single first request, for example, for a particular fingerprint of traffic. That's why I also mentioned saying, for example, some particular networks, you might want to always have them inline, because you are reducing the risk, and you might be able to afford adding the latency for those particular segments of the network. Yes?
I'm interested how you...
For the viewers at home, Gary?
Hey, I'm interested in your profiling the different fingerprints. Do you notice that most of those fingerprinted attack patterns come from generic web browsers and not from your pre-configured apps? Like I'm just looking at apps in an app store for your like booking.com thing is essentially back to a fat client where you've got better control over the characteristics of how that app behaves.
Are you whitelisting app connections versus web browser connections? I think is
right.
Where you going with that?
Thank you.
Yes, so on purpose, I'm not describing how the booking.com solution is, but how a similar architecture can be implemented. What I can say from fingerprints is user agents are not a good fingerprint. It's very easy to fake, and most people already have headless browsers which are using like regular user agents. But something that always surprised me is how good IP addresses are as a fingerprint just by themselves. You shouldn't just use one, but they're better than you would expect a lot. You always want to do combinations of them because it's very hard to fake all the combinations. And even then, if somebody has a massive botnet and it's doing everything right, worst case, at this huge attack, suddenly a percentage of your traffic now has added latency. So it's not like you're just dropping it. Yes. So I will have more questions afterwards, but just to go through a summary. As I mentioned, the benefits are you have the reduced customer impact. So you only add the latency to malicious actors. by doing this, you also stop the false positives because only them are suffering from the false positive rate. And you can specify different behaviors based on the application's risk, and their threat model, and how they actually work and what do you care about them. And the other point here, having it as a service now adds a lot of flexibility, not just because you can add any components you want, so you can code your own or plug different solutions, so you don't have to decide between mod security and NACSI. You just can use both, and then have an ensemble decision or whatever you want. And it allows to iterate very rapidly, so you could just say, if you're going with the agent or the library mode, it's very thin, especially with the library. Developers are very used to using API calls, so you can just tell them, do an API call with this information, or you give them this library, and it's a very easy way to bootstrap them and to give them an idea. And they feel a lot of power because they're very used to this. They can use their code around it if they want. So yeah, this is on GitHub. So for this case, you can just use Terraform to set up the same thing, and it will just run on your Google Cloud project. And now if you have any additional questions.
We have 3 minutes if there's anybody else with questions. This has been an absolutely brilliant talk. I've worked in this sort of space and built my own stuff, but my dream was to do something similar so we could actually do some detection and monitoring out of band as well as doing the whitelisting and inspection at the front end for stuff that we know we need to protect. So this looks fantastic.
Cool,
Thank you.
Thanks.
Okay, does anybody else have any questions? I think everybody's stumped. My next question was going to be, is there an open source project around this that we can actually use a framework to actually bootstrap this same sort of solution? So this is absolutely fantastic. Thank you.
Yeah. So from my point of view, I don't see it as I see it more as an architecture than as
exactly, yes.
So that's why the whole code is there in GitHub. So you can look at all the different services I used for the talk. If you run the script, it will create your own Kubernetes engine with all the different pods, and then you can just play with it as much as you want.
That is fantastic. Oh, well, can everybody else help me thank Juan for this? This is actually...
Thank you very much.